EP, I think we can start.
Okay, let's get started. So welcome everyone to the session about the business reporting with Azure Serverless components. And my name is EP or Eetu-Pekka, and I'm here with my colleague Igor to talk about the use case around Autocloud Marketplace. And my part is going to go through some of the components that we'll be introducing with around Autocloud Marketplace and Azure Serverless. And then Igor will show in practice how we can build such a solution. Okay, so let's start talking about Autocloud Marketplace very briefly. So I think most of you, or like some of you, might already be familiar with the Autocloud Marketplace, but just to go briefly through what the marketplace is, or actually I could talk next 45 minutes about the marketplace, but let's just leave it there. So Autocloud Marketplace is a platform that our partners use to purchase different kind of cloud solutions from our partners and from our vendors and providers. Of course, such a thing includes a lot more as a platform. So of course, there's invoicing, reporting, ordering. I could go on and on. But we're gonna focus on this session automation and moreover to single functionality on top of Autocloud Marketplace, which is called Simple API. So what the Simple API allows us to is to forget the UI, the web UI that we'll be normally using when we're operating on top of the platform. And we go a bit deeper into automation and use programming to automate actions on top of the platform. So what the Simple API then is, it's a REST endpoint where we can call information or we can push information. It's free to access to anybody who has the access to the Autocloud Marketplace. And it allows our partners to automate their processes, get certain data, get certain billing information, get certain actions done on top of the Autocloud Marketplace. So this is one key component what Igor will be showing in practice as well in the following 45 minutes. In addition to that, we'll be talking about Azure Serverless components that will be used in this masterclass as well. So the following components that we'll be talking about will be Azure Logic Apps and Azure Functions. Just to go briefly over these components on top of Azure is these are very similar way they allow us to automate, but on Azure Logic App side, we have a workflow approach. It's a drag and drop actions that we don't have to actually write any code to do automation. It has a large collection of already made actions that we can just drag and drop and start doing different kind of automation on top of Azure. And it also has a large collection of connectors. So wherever we want to attach the logic app to, it already probably has a connector who somebody created already. Especially when we're talking about Microsoft, first thing that comes to my mind is, for example, Azure AD. We can directly connect to the local Azure AD Active Directory to, for example, queue some user information. But when we move towards the Azure Function side, we actually have to create the code. We actually have to code a bit to create those actions. But this allows us to customize even more, since on the Azure Logic App side, these components and actions are actually locked. So this Azure function side gives us a more flexibility over automating our processes. Of course, the Azure function also has a lot of built-in binding types that we can use in a similar way with the connectors, but it needs a bit more programming approach. And Igor will talk about this in the practical session. But now that we've briefly talked about the components that we'll be using, in addition to the business reporting, the Power BI is also from Microsoft a key component over here. But now that we've talked briefly over the components, I want to talk about different kind of solutions that our partners have already created. And to go through some of the solutions that they've already created, I have 4 examples. So these are actual practical implementation of simple API using the Azure Serverless components. So if we start from the left side, a local custom webshop integration, we have a partner who's actually fetching all the pricing information from the Autocloud Marketplace into their own webshop. So whatever changes the partner is doing on top of their custom webshop, they're actually updated, automatically into the webshop. And this is done by Azure Functions. And
EP, you are muted now.
Eetu-Pekka, me ei kuulla sua. We can't hear you.
hello.
Yep, we can hear you
Much
now.
better.
Yep.
So sorry about that one. It seems that I've been muted by someone. Sorry. It's all right.
It was my fault.
Don't worry.
Because
It's fine. It's fine.
Unfortunately, when somebody enters the meeting with the mic on, so we cannot search for the 100 people.
Let's continue. It's fine. So one of our partners created their user integration on top of the Autocloud Marketplace with the similar serverless components from Azure. So what they did is actually they're syncing their users based on certain groups of Active Directory into the Autocloud Marketplace. And the next Visma and the Business Central integration that our partners have created are actually invoicing integration. So our partners are actually matching their invoicing data on top of the Autocloud Marketplace automatically into their own ERP systems. And all of these 4 have common that all of these solutions have been actually created by using the Azure Serverless components that I earlier mentioned, Logic App and Azure Functions. So all of this automation, the middleware that we could call it, is Azure is being used in the background. It doesn't have to be Azure. There are other options as well, but in these components, it's been just so easy because there's always some Microsoft components in addition to that. So it's easier to use the Azure Serverless components to create these kind of automations. So next, what I'm going to talk about is what does it actually look like when we are integrating with different kind of systems. So in here, briefly, we can see on the left side, we have the Autocloud Marketplace, we have the middleware plugins, logic apps and functions, and we have the data storage. In here, most precisely, you can see the Visma. So this is actually the flow, how Azure Logic Apps and functions are actually fetching the data through the simple API of an Autocloud Marketplace and pushing it in to the Visma or SAP or Salesforce or SQL database. For example, SQL database that we can later on attach to a Power BI reporting. Or if you already have existing Power BI reporting attached to SQL, just flow the data through from the Autocloud Marketplace into your SQL and then go forth with showing the advanced reporting in forward. But Then another thing is that we need to remember that there's another way of doing this as well. So we can add another component here, which is actually another ERP or a web shop in this case that can actually send the data into the Autocloud Marketplace, and then a similar flow with the invoicing will go on. So we have full-fledged automated process from ordering to invoicing without actually accessing the web UI at all. And with the simple API, we can create this kind of flow, and Igor will next show an example how that can be created. Igor, stage is yours. I promised to take 10 minutes. It's 15, very usual of mine. Sorry about that one.
No
go
problem.
ahead.
Yeah, thank you. So basically, before we start with the demo itself, I just wanted to explain something about the function app itself. So basically, the different consumption plans regarding the function app, each with its benefits and behavior. But what is also important, it's also important that, for example, in this case, we will going to use a PowerShell. Why we choose PowerShell? Because if you are a system integrator, then there's a big chance that you have people using PowerShell already in your company to automate different tasks regarding server automation or environment automation. So basically, the same knowledge can be utilized to create a function app which is using PowerShell core as a runtime. At the same time, it's no problem to use .NET Core, Node.js, Java, Python, whatever you want, whatever the runtime or development tool that you are using to produce the function app itself. Through the different consumption plans, there are some limitations on the execution time. For example, if you are using the consumption plan, you have 5 minutes minimum default execution time, or the maximum will be the 10 minutes execution. Please bear in mind that if you are using HTTP triggers for the function app, then basically the execution time is limited to 230 seconds, because this is the limitation in which time frame the load balancer on Microsoft side is expecting the answer from the function app. So if you want to have, let's say, long-running function app, but you need to provide a short answer that you have accepted the request for the execution, what you can do, you can use Azure storage account and utilize the queue. So basically, you will have a function app that will accept the HTTP request. It will push the message to the queue. Then you will link this queue to another function app that will basically execute the action itself. So this is the way how can you go beyond this limitation of the load balancer itself. Also, there are differences in the maximum number of instances between the consumption plans. So basically, if you have some actions which are short running and basically you need a fast response to the request, then you can use a premium plan, or you can use a dedicated plan. But for example, you can also do a combination that, for example, endpoints which need a fast response will use a premium plan, but those who will be attached to the queues can use, for example, consumption plan. So it can be mixed. Let's talk about what we're going to show today. So for example, let's have a challenge where we have a service portal. Let's say we have our own ERP, and one of the parts of the ERP is self-service portal where users can adjust the number of licenses. So what will be the point? So the point will be that those licenses, which could be as a product in the ACMP, will be updated through the service portal, but the service portal itself will trigger the logic app, and then the logic app will do the change in the Autocloud Marketplace itself. On the other hand, since we have Autocloud Marketplace as a one-stop shop for cloud services that we are selling and our services that we are selling to our customers, we want to have the reporting from that environment. We want to have a reporting from Autocloud Marketplace in the Power BI, which can be then integrated with our ERP reporting. So what we're going to do, we're going to use Function app to extract the invoicing data from the Autocloud Marketplace and push it to the SQL database that will be later displayed in Power BI. If you look at the solution components itself, we have three major components here. We have the Logic app, we have the Function app, and we have the Power BI. On the other hand, we also have some supporting components. We need a key vault, we need a managed identity, we need a SQL database to store the data, and basically we need a storage account that will help us to run the Function app itself. What will be the steps? First, we're going to create a Logic app that will be triggered by the self-service portal. That Logic app will update the product quantity in ACMP. After that, we're going to create a scheduler function in the Function app that will basically transfer the sales report from the ACMP to the reporting database every second day in the month. And in the end, we're going to use Power BI to connect the reporting to this database that we have created, and we're going to have sales report visualization from that. Look how this looks in a demo. So basically, this is the Azure environment that we have created for this case. What we have here, we have app service plan, which is used for our Function app. We have SQL database, we have application insights for the Function app itself. We have the Logic app server for the database. We have a key vault where we're going to store all the connection secrets for ACMP, for SQL database. We have an API connection which will be used from the Logic app to connect to the key vault. And also here we have managed identity. So what is the point of the managed identity? The point of the managed identity is to simplify authentication toward different services in Azure. So for example, if you have a Function app, Logic app, if you have virtual machine, you can use managed identity to authenticate that service to key vault, to storage, whatever you want. What's the difference between managed identity, user-created managed identity, and the system-created managed identity? The difference is basically in the lifetime. So if you create a user service identity, the same service identity, managed identity, sorry, can be attached to different services. So basically, if you have one managed identity that will be used by 5 different Logic apps or 5 Function apps, that same managed identity can have certain rights on the key vaults or on the storage. If you're using system-generated managed identities, their life cycle is equal to the life cycle of the component itself. So basically, when you delete that Function app, that managed identity will stop to exist. So basically, it will be deleted. So therefore, you need to maintain the authorizations and links to different services. How this looks in the case of the key vault, for example. Let's start with the key vault where we have different secrets. So what we did here, so we have created a secrets that will allow us to store the connection information for the ACMP and for the SQL database. When we look at the access policies, we can see that this managed identity has certain rights to certain elements of the key vault. So if we go back and look at the Logic app, that will be the first on our list to work on. So basically, here we are using this same user identity, which is assigned to the Logic app, and basically that Logic app will use it to access the data in a key vault. Let's go back to the Logic app itself. So basically, when we create a Logic app, what we're going to get? We're going to get user interface, which can be used in a visual way to create an app. So how does it look like? When you edit, you're going to start with some kind of request, some kind of event. Does it relate to the new email which is created? Is it a HTTP request that will be created? You have different types of triggers that you can utilize to start your logic app. In this case, we're going to use HTTP request. So basically, for a HTTP request, what we're going to use? We're going to use a JSON body, which will send us the information about the product, quantity, and customer account ID. How can we generate this JSON schema? We can generate it by just using the JSON from the request itself to generate simple schema, or we can create the schema ourselves and put it in here. So the next thing for us will be to get the secret from the key vault. So basically, we saw that we have a connection. So we created a connection which is using managed identity for the certain key vault. And then we have the option to select which secret do we want to fetch from the key vault itself. The next thing for us would be a call to the Autocloud Marketplace API, simple API, to authenticate ourselves. How are we going to do that? So basically, we have a post method, we have the URI for the link, and basically for the body of the request, we're going to use what we are getting from the key vault. So in the key vault itself, we have a JSON which consists of the username and password. The next step will be basically to store the information that was given to us by this previous call, and we're going to store this token to the certain variable. So we have created a variable which was a string type, and we took the body of the previous call. The next thing will be, for example, to get a list of subscription for the customer. So why that? Because, for example, if you're going to create a logic app that will work with the different customers could have different IDs for the certain subscription, but the name of the subscription will be the same. So basically, what we're going to do, we're going to fetch the list of the subscription for a certain customer, and then we're going to cycle through that, and we're going to check which subscription do we basically need to increase. And to do that, we need to take the subscription ID. So we have, again, a post method with the REST API to the simple API. This is the URI. So we have to authenticate first. We're going to authenticate, put the session ID, and we're going to use this variable that we have defined here. And what we're going to say, we need a customer account ID, which was passed to us in the initial request. After that, we're going to get JSON with a list of all the subscriptions. The next for us will be basically to parse this JSON. So again, when we are parsing the JSON, we can use a sample payload to generate the schema. And after that, we can modify this schema and, let's say, exclude the fields that are not needed or change the type of certain fields. So it's up to us to define this. After that, we're going to need to define the variable for the subscription ID, account ID that we're going to use to trigger the action itself. So the next thing will be to cycle through all those subscriptions that we got from the parse JSON. So we are taking this body from the JSON. And we define the condition that the service name, which is the field in this JSON body, should be equal to the product ID that we are getting from the initial request. If this is the true, what we're going to do, we're going to set subscription account ID with the current account ID in the JSON. And after that, we're going to trigger another simple API call that will basically update the subscription. This time is a bit different. Authentication in the header is still the same, but the body itself is changing. So you have to look at the API documentation to see which call has which required fields. And basically what you're doing here, you're populating the fields with the values from the logic cap steps itself. So we have the subscription account ID, which is a variable. We have the quantity, which is coming from the body of the trigger itself. We have the parent ID and the service name, which are also coming from the initial request. So another option for you is to see the code of this logic cap. Why to see code? Because sometimes, for somebody, it's easier to change the code here to update something than to work visually in the designer. Also, if you copy this code to the clipboard and later paste it on, the same visual will be built from that code itself. Another option for you now is to run this. So if you have the JSON, which will be included in the trigger, you can run this and you will see what will happening. Or you can go back here and watch what's happening with the executions. So let's look at the Autocloud Marketplace. In the Autocloud Marketplace itself, we have this demo customer, and we have this My ERP as a product, which currently has just one license. So what we want to do, let's say that we started from the service portal, we started a trigger that will increase the quantity to 50. We send this, and basically when we go here and refresh, we see that it was executed. If we go into Autocloud Marketplace, we refresh, we see that there is a change in the number of licenses. Again, we can say, okay, we forgot, we want 70 licenses. Again, we are sending the trigger, and we will see another runtime, which will be executed, and of course, the value here will be changed. When you want to see the execution process of the logic app itself, what you can do, you can click here. You will see the same flow. You will see the execution time for each element. But what you will also see, the initial calls, you will see the returns, you will see everything that was happening basically in the background. Also, for example, if you have a large workload or you have many requests for the logic app itself, what you can do, first, you can enable this, which is high throughput, which will enable you to run high volume of the requests on the logic app itself. Also here, you have the option to limit the IP range from which you can call basically this logic app, which is fine if you have your own ERP system hosted in the cloud, having some range of the IPs, so you don't want anybody else from the external world to call this same logic app and to trigger something. Also, here you have the option to specify the retention days in the retention history in the days. So basically, you can use the default, or you can change it to 30 days, 180 days, 90 days, whatever you like. So this was the part where we've shown that you can use a logic app to create simple integrations. Please bear in mind that, for example, Coca-Cola, which is a large multinational company, is basically using logic apps to automate the complex integrations. So it doesn't have to be that you're using logic app just for the simple stuff. It depends how this complex integration is structured. What connectors do you need? So basically, with the logic app, you can even have connectors for the SAP. So basically, you can automate the stuff which is related to the different ERP systems. For example, if you need to take the data from the production line, push this data from the production line to the SAP, it can be also done with the logic apps, no problem. Other option here is that basically what you can do, if you create a logic app which have some elements, it has some triggers, it's doing some actions, you can export it to the Power Platform. So if you are using the Power Apps, you can utilize this logic app as an external connector in the Power App, and you can basically trigger this same logic app from the Power App interface and from the Power App workflow. Okay, the next thing that I want to talk with you about is basically the function app. We spoke about what are the options of the function app, what can be done with the function app. So let's look at the function app itself and how it looks like. It's a little bit more for the, let's say, developers. It's not so, it's not defined by the user interface. You have to code, but it also has a great flexibility. So for example, you have deployment slots. What this means for you? That means that basically you can have your production slot with a working app. You can add your development slot where you are developing your app itself. Sorry. And basically, when you want to switch those, you said, okay, my app is now finished. I want to make it production. You can easily swap those slots, and in a few seconds, you will have your development application, your development slot as a production slot. Let's say after 2 hours, you figure out that, yeah, there's some bugs, we need to fix this. You can easily return back to the previous production and basically just swap them back. Regarding the deployment center, so there are different options to deploy the app. You can code directly in the user interface of the Azure itself, but you can also use, for example, you can use GitHub, you can use Azure repos, you can use OneDrive, Dropbox, whatever you want. If you are using just some simple application, you can use just the FTP credentials to connect to this app and to update the source of this app. We also spoke about the identities. So basically for the function app, it's pretty much the same like for the logic app. You can have a system assigned managed identity, or you can have a user assigned managed identity. I just explained why I would rather use a user assigned managed identity. The thing is that you can have multiple user assigned identities, but at the execution cycle, you can use just one. If we are going, for example, to look how the app itself is looking, you can go here with a preview, and basically we can see the structure of the app itself. When you are working with a PowerShell, there's one thing that you can enable, and that's the fact that here in the settings, you can enable that Microsoft will manage the modules for you. So basically you specify which modules do you need and which version do you want to maintain. And the Microsoft in background will check, is there a new version of that module, and will upkeep those modules for your function app. This is nice, but sometimes it can have some consequences on the performance side. So what you can do, you can say that you don't want managed identities, but you can create a modules folder, and then you can use save module option to manually keep the modules for a function app. You will get a better performance, and basically you will be able to upkeep the exact versions of the modules that you need. Also, you have here the profiles. So the profile is basically a PowerShell script which will be executed before each function app is executed. So basically, if you need to put some common functions, you can put them in here. So they will be preloaded before the executing each of the functions. Okay, let's go back. And let's create a function. Okay, let's go to the functions. We're gonna add a function. In our case, we're gonna use timer. We're gonna name it get CMP invoice aggregation, and for the schedule, let's say we're gonna run it 4 in the morning every second day in a month. Sorry. Okay. Add. So what's happening now? The Azure will create the app for us. And basically here we can go directly to the code of the app, or we can look at the integrations. So what the integrations are? So basically you have the trigger, which will invoke the function itself. We have the function, but we can have different inputs to the function itself. So we do, for example, if you want to fetch something from the storage, you don't have to code it. You can put the parameters, which will fetch something from the blob storage and provide it in your function. You can do it manually, but this is the simple way. Same goes for the output. For example, you accept the request, you want to push this request to the storage queue. You just select, OK, Azure Storage Queue, and this will be pushed to the Azure Storage Queue. Let's go to the coding of the function itself. So what we have here, we have the function code, initial function code. We're going to replace it with our own code that we have here. And we'll just briefly go through the code. So this is the parameter that we're going to get from the invocation of the function itself. Next, we're going to need to fetch the credentials from the key vault. So basically, what we're going to use here, we're going to use managed identity to connect to the key vault. And basically, we will fetch this environmental variable that we have defined in a function that will hold the name of the key vault. So basically, we can parameterize everything. After that, we're going to need to generate the report date. We're going to get ACMP session token. So we're going to authenticate to the ACMP. After that, we're going to get the information about invoice aggregation report. So basically, we're going to invoke this report from the API. And if everything is successful, we're going to go through the rows that we got from the simple API, and we're going to insert them directly to the SQL database. So what we're going to do now is we're going to just test this. So basically, when we say we want to test this, we're going to maximize the window. And before we do that, I'm just going to briefly show you the Power BI report, which we have here. So basically, we already have the customers inside, and we're going to add product sales. So if we run this, okay, we see that it's accepted. The function started. Okay. We see the output, we see the authentication. We see the different elements that we put. So basically, we have the report date, which is generated. We authenticate to the ACMP. We are fetching the report data from the ACMP. And after that, we are just pushing the data to the SQL database. Okay. So the function has completed in 41 seconds. If you go here, and basically, if we refresh the data, we should see the sales data in the table. when we are talking about the Power BI in this case, so what was important for us? For us, when we go to the SQL database, it was important for us to specify the firewall rules so that basically Azure services will have access to the database. We don't have to program authentication of the IP address for the Power BI. So we just need the credentials for the database. And basically, with this, we made an exception in the firewall that will enable different Azure services to access this database. And basically, if we're talking about the Power BI in this case, this was done with a direct query, but depending on your needs, you can use either with, you can use import mode, you can use direct query mode, you can use hybrid mode. Basically, everything depends on the performance that you want to achieve and basically how fast you need to refresh the data, which will be shown in the report itself. So basically, this concludes our demo. I don't know if you have any questions.
Igor, I have a question for you.
Yep.
So let's say that I would like to build a reporting solution by using the SQL database as a service, logic app, and a function. What would you estimate if I would like to only get one reporting, a very low performance, not too much? What would be the cheapest option to build such a thing?
The cheapest option would be logic combination of the logic app, SQL database, or even storage table, which can be then connected to the Power BI. And basically, depending on the number of the requests, we are talking about a few euros per month.
Exactly. Yeah, this is what I wanted to point out, that building this kind of custom reporting for your customers or for your own use, it's a couple of euros a month by using the serverless components here. So it really makes sense to use these serverless components over building something locally, since the cost is really low.
I think that big thing here is also the maintenance of this logic. So basically, if you go the old-fashioned way, you hire some developer which will build the solution, which will build the integration. Somebody will have to upkeep this integration. So basically, if you need to change something, that's probably additional cost for the integration. What's going to happen with that after 3 or 5 years? Who will maintain this? So those are the questions which are also raised. And basically, Logic App, with its visual approach, basically simplifies the maintenance of the logic itself.
And if you're personally familiar with Power Automate, it's really easy to pick up the logic apps. Azure Functions might require a bit coding knowledge, but the logic apps is something that everyone with a little bit logic understanding behind is easy to build. And yeah. Any questions from? I didn't pick up any questions from the chat. You're free to speak out. We can cut off the recording for now and just speak out if you have any questions regarding building such a solution, or yeah.